Hello. In this video, we are taking a look at the example of finding the integral of x to the fourth minus 3x cubed minus x squared plus 1 all over x cubed plus x. Now, we know we're in the section of partial fraction decomposition. We want to set up a partial fraction decomposition for this. And using our previous examples as practice, and reference, we have done that we want to break this up into a set of smaller fractions where the denominators of the fractions are the denominator of the big one factored. So factoring x cubed plus x is x times x squared plus 1. X squared plus 1 cannot factor any further. And if we set up the partial fraction decomposition for this, we'd have a over x plus bx plus c all over x squared plus 1. As we have a linear and we have a quadratic, we put a constant above the linear and we put a linear above the quadratic. But if I were to combine like terms on this, I would get a times x squared plus 1 plus bx plus c times x all over this x times x squared plus 1. And if I multiplied this out, the highest power I'd get is a squared. But I need it to be a fourth. I need a fourth degree power. So what this actually means for us is we need to do a step before the partial fraction decomposition. And that step is long division. And we are going to use long division when the degree of the numerator is greater than or equal to the degree of the denominator. So looking at that denominator, it is a cubic. So if the numerator is a cubic, we need long division. If the numerator is a quartic, like it is, we need long division. If we have a 6th degree power and the denominator is a cube, we need long division. As long as the numerator power is bigger, we need long division. Or if they're equal, we need long division. So first, we actually want long division. So setting up the long division with this problem, we're going to put x to the fourth minus 3x cubed minus x squared plus 0x, there's no x's, plus 1 inside the box, and x cubed plus 0x squared plus x plus 0 on the outside. Putting zeros in for the powers we don't have. And using this process, the first step is to look at the first terms and divide them. X to the fourth divided by x cubed is x. So that's going to go up at the top. Then we're going to multiply. So take this x and multiply it by everything out here. So x times x cubed is x to the fourth. X times 0x squared is 0x cubed. X times x is x squared. And x times 0 is 0. Now subtract. So subtracting everything. The whole point of that first division is that the first term will cancel. X to the fourth minus x to the fourth goes away. We have 0. Negative 3x cubed minus 0 is negative 3x cubed. Minus x squared minus another x squared is negative 2x squared. 0x minus 0x is 0x. And then we bring down that 1. And then repeat. Look at the first terms and divide. Negative 3x cubed divided by x cubed is just negative 3. Negative 3 times everything out front is negative 3 times x cubed is negative 3x cubed. Negative 3 times 0x squared is 0x squared. Negative 3 times x is negative 3x, and negative 3 times 0 is 0. We subtract. Negative 2 minus 0 is negative 2. 0 minus a negative 3 is a positive 3. And 1 minus 0 is a positive 1. We stop when our degree of our remainder is less than the degree of the divisor. So we have a quadratic that is smaller than a cubic, meaning that is our remainder. So this now means that our original fraction is equal to what is above this bar, x minus 3, plus our negative 2x squared plus 3x plus 1, all over the x cubed plus x. And x cubed plus x we already know is x times x squared plus 1. Now this we can use partial fraction decomposition on. And when it comes to doing the integral, we know how to integrate x minus 3. The integral is x squared over 2 minus 3x. So we know how to integrate that part. We just need to use partial fraction decomposition to figure out how to integrate the other part. So let's now do that partial fraction decomposition. We are going to do partial fraction decomposition on this fraction. Negative 2x squared plus 3x plus 1 over x times x squared plus 1 is equal to, we said before this would break up as a over x plus bx plus c over x squared plus 1. Multiplying things out, this gives us negative 2x squared plus 3x plus 1 is equal to, we're multiplying by this denominator. So when I multiply by a, the x's will cancel. I get x squared plus 1. And when I multiply bx plus c by x, I get plus bx plus c times x. Multiplying all that out, negative 2x squared plus 3x plus 1 is equal to ax squared plus a plus bx squared plus cx. Setting up our equations, the x squared terms have to add together. So a plus b has to equal negative 2. X squared plus x squared equals that x squared. our x's have to add together to be 3. So C is 3. And finally, our constants have to add together. A has to equal 1. That means if A equals 1, B equals -3, because 1 minus 3 is -2. That now tells us that if x to the 4th minus 3x cubed minus x squared plus 1, it all over x times x squared plus 1 is equal to x minus 3 times this fraction. And this fraction breaks into a over x plus bx plus c over x squared plus 1. That tells us x to the 4th minus 3x cubed minus x squared plus 1 all over x times x squared plus 1 is equal to x minus 3 plus a over x, 1 over x, plus b x plus c all over x squared plus 1. And if I want to find the integral of this first part, that is integrating the second part. We're integrating x, we're integrating 3, we're integrating 1 over x, we're integrating -3x over x squared plus 1, and we're integrating 3 over x squared plus 1. We know the integrals of all of those. The integral of x is x squared over 2. The integral of 3 is -3x. The integral of 1 over x is the natural log of the absolute value of x. The integral of -3x over x squared plus 1, that would require u sub that we saw in a previous video. That will come out to be -3 halves times the natural log of the absolute value of x squared plus 1. We'll use a u sub of x squared plus 1. And then 3 over x squared plus 1 is arctan. This is plus 3 of arctangent of x plus c. So if our degrees are not, if the degree of the numerator is not smaller than the degree of the denominator, we need to start with long division. And then after the long division, we can set up our partial fraction decomposition.